Hello, everybody. I am particularly happy to welcome you on this first ever webinar on ArmoniK. ArmoniK, you will discover it. It is the new modern grid orchestrator that has been built by Aneo for CIB, but also able to address industrial and healthcare simulation use cases. It's open source. It's very performant to manage huge graphs of computation tasks on a hybrid environment, meaning on cloud and on-prem at the same time. And today's objective is to give you an overview on the product and a feedback on its first production deployment. So let me first introduce the two other speakers. So first, Wilfried Kirschenmann, who is the CTO of Aneo, Head of Research and Development, and he has led the architectural design of ArmoniK. We can test the mic.
Yes, here I am.
And second, Marcel Fan, which I thank a lot to be present today, which is the Deputy Head of Crédit Agricole Capital Markets IT, where ArmoniK has been live since last summer.
Hello, everybody.
Okay, thank you. So personally, I am Thierry Pécou. I'm a former CIO in capital markets at SocGen and BNP Paribas. And since 11 years, I am a partner at Aneo in charge of consulting IT. And today, I'm especially managing with my hat of managing ArmoniK go-to-market and sales. So I will cover the history of the product. Then Wilfried will present the product. And Marcel, as I told you, will present the success story at Crédit Agricole. In terms of genesis, so ArmoniK has been built by Aneo. Aneo is a consulting company born in 2002. Aneo is, since the first 2 years of its creation, an HPC grid specialist, which has worked a lot for French CIB and French insurance. And we have implemented, audited, or optimized biggest grids. For example, we have also built the first GPU POCs and implementation. At the same time, we've built partnership with top chip makers, namely AMD, Intel, or NVIDIA. And because we are doing the tuning of end-to-end risk architecture. I'm trying, yeah, the click is working. So I switch the first decade. So we have expanded and we have especially developed specific monocloud orchestrators for CIB clients, but also for industry and insurance. And it was the time where cloud was emerging. At that time, we've built partnership with the biggest one, so namely Azure, AWS, and GCP. And we started to get requests from clients to replace their IBM Symphony or TIBCO DataSynapse installation, which was starting to become a little bit outdated and which was not welcoming natively the cloud. So then what we have done is we have also developed, because we were partnering with them, the first OVH and GCP integration for IBM Symphony. And we have started at that time to engage strong discussions with CIB clients to build what we used to call at that time the hybrid grid meta orchestrator. And the stars were aligned 2 years ago, where we have built with Crédit Agricole on one side, AWS on the other one, a tripartite partnership to build ArmoniK in open source. And you will discover what it means. And especially interesting is that at Crédit Agricole, for historical reason, they had both implemented DataSynapse on equity risk chain and Symphony on the global market chain. Then we have built the product within the course of, let's say, 18 months. And it has been live since last summer, first in global markets and then in equity just after. And the target, probably Marcel will explain to you that, is that at the end of this year, ArmoniK will have totally replaced both DataSynapse and Symphony on-prem. So today, the ArmoniK is a bulletproof product and it is what we describe as the modern open source orchestrator, which has been proven as able to replace DataSynapse and Symphony, and which has been especially designed for CIB, but also which is able to replace to manage use cases in healthcare and industry. And his goal is really to distribute huge graphs of computation tasks at the same time on premises and in multi-cloud. And now, Wilfried, I let you the floor to explain the product. Thanks. You're in mute, I guess.
Yes, I was. Thank you, Thierry, for the introduction. Now I will describe a little bit more what ArmoniK is and how it works. So first, I want to introduce the problems that are solved by ArmoniK. And we have two kinds of problems. Some are technicals and the other one are organizational. So let's first dive into the technical issue that we try to solve. The first one. Okay. So the first one is basically the same thing that IBM Symphony or Tyco DataSynapse are doing. We want to process tasks on a distributed infrastructure. We want to process this task either on-prem or on one region of AWS, for instance, or on another region from AWS, for instance. And we want to be able to manage node failure. We want to be able to manage task failure, to monitor the advancements of the computation. We want to optimize the resource usage. We want to have different kinds of scheduling policies and so on. And that is something that a grid scheduler does, and ArmoniK is one of them. But we have also other issues that we want to address with ArmoniK. It's the fact that we want to be able to schedule graphs of tasks, which means that we want to take care of the dependencies between tasks. So what we do is it's not a requirement, but it's better if you do, because you will have services provided by ArmoniK, but you can describe your workload as a graph. Here on the schematic on the left side, you can see the squares. These are data. And these data are used to run some computation. And this computation provides new set of data. Some of them are results, and other will be intermediate results that are required for other computation until you get the final result. And ArmoniK will take care of scheduling a task only when all the dependencies are available. So it will take care of managing the dependencies. It will support having a dynamic graph, which means that if, for instance, the solver A on the right-hand side of the schematic dynamically says, okay, this problem that I have to solve, the computation request that I have is too big for me to handle it by myself, it can spawn new tasks. And these new tasks will be scheduled by ArmoniK, and it will be completely transparent from a user point of view. And the client that is waiting for the result, it will be transparent. Something that I said is very important. We are not waiting for a task. In the model of DataSynapse or in the model of Symphony, you are waiting for the end of a task. In the model of ArmoniK, you wait for a result, you wait for a data, because ArmoniK is data-oriented. And as you are waiting for the data, it means that if the tasks that you're responsible to producing the data changes, because there is a failure or because there is a change in the graph, the client that is waiting for this final result, it's completely transparent for it. So you have a bigger decoupling between the client and the worker. In ArmoniK, as with Symphony or as with DataSynapse, you can have a kind of a state within the nodes that are running the solvers. For instance, you can have the library initialization that is cached between runs and so on. And we will see later, we'll explain it in the architecture, but we provide some overlapping between computation and data transfer. And this feature can be provided because ArmoniK is aware of all the data dependencies. So all this feature about the scheduling of large graph of tasks is something that is quite new in the field of grid computing, at least in this way of doing things. So now we have other kind of benefits from Harmonica. Because Harmonica is open source, it can help a cultural transformation of a company. I will describe this very briefly because I think that Marcel will have some testimony to do about that. But basically, as Harmonica is open source, open, and that we are welcoming collaboration and we are welcoming contribution, it helps changing the culture inside the company. It helps changing the culture for the IT quants because if they have some requests, if they want the product to evolve, they can either collaborate with us or they can do it themselves and contribute to Harmonica. And that is something that is very empowering and very attractive if you want to hire some talents. Harmonica also allows quants to implement more complex compute workload than they used to do. Currently, either the quants provide only massive parallel algorithms, which means you split the computation into many tasks and you get one result, or you have to develop your own graph dependency scheduler and you have to develop your own code that is waiting for some results, aggregating the results, and then going to the next step of the computation. Now you can directly branch Harmonica to the quant library and allow the quant to express their algorithm and to express their programs as a graph and directly execute it. Harmonica also provides elasticity everywhere we see in the architecture, which means that we have a completely scalable and we don't need to go into all the details when you are deploying Harmonica on the number of servers and the size of the server that you need for the broker, for this component and so on. It's completely horizontal and elastic. And Harmonica also provides a lot of security features, and one of the security features provided is the role-based right management, which means that we don't have to manage the rights user by user, but you can manage the rights by affecting user to some kind of role, and this role will be used to define the rights that are used in Harmonica. The other kind of transformation that is brought by Harmonica is IT modernization. Why IT modernization? Because Harmonica is natively built to run both on cloud and on premises. So you can deploy it in any Kubernetes environment. We'll see that in the architecture. And as it's based on Kubernetes, it's aligned with most IT stacks. We see more and more customers moving their IT component to Kubernetes. And back in the day, grid computing were considered another kind of citizens in the IT scape with in the IT landscape with specific rules, with specific machines, with specific orchestrator, and with specific production teams. And now, because we are running on Kubernetes, we can mutualize some of these teams, we can mutualize some of these processes, we can mutualize some of these security rules. And that is something that helps for the IT modernization. Harmonica also helps for the code modernization because Harmonica provides some SDKs in different languages. And as long as it's available with the language, we try to enforce async programming. We try to enforce the fact that your library will be as parallel, will harness as much parallel power as possible. And of course, Harmonica provides lots of monitoring tools and alerting systems that can be integrated with your homemade systems, and we'll be discussing that just after. And as far as we know, Harmonica is the only open source solution to answer this problem, and it's been live for a bit more than 1 year now, as Thierry said just before. So on the architecture side, This is the architecture from a high-level point of view. What you can see is the dark blue component are the APIs and or SDK, depending on where you stand. And on top of that, you can build whatever you want. On the top of the administration API, you can build your own customized admin page or your own customized monitoring page. We provide also some of them, but if you don't like the design of, if you want to integrate them with your system, you can do that. And you have on the light blue components, your computing application with the client on the top left, and maybe your external storage, your external data store, if you need to access Sophis databases during the computation, or if you have a dedicated data cache, you can use it. We prefer that you do not, because if you do that, you lose some functionality from ArmoniK. But if it's required from an architectural point of view on your side, it's feasible. And we have within the worker API in the middle, the two light blue up1 and up2, which basically are your computing libraries. These are your solvers, and your solvers will be called by the ArmoniK runtime that is running on the different nodes. So something that is very important to keep in mind is the fact that ArmoniK can handle what we call partition. These partitions are defined at deployment time, and this partition will allow you to deploy different applications at the same time, or different versions of the application at the same time. And in the near future, this will become dynamic, so you will be able to do that without changing the deployment of ArmoniK. Now we have the internals of ArmoniK. I won't go into much detail. What you have to know is the fact that everything can be run within Kubernetes. Can, but it's not mandatory. We have our control plane. Basically, the control plane integrates all the services required to implement the administration and client API. The control plane is communicating with the data plane. I will describe the data plane just after. And the data plane is communicating with the compute plane. And the compute plane contains all the compute nodes. And the compute nodes are running the scheduler and the lib agent that is hosting your solver. The data plane can either be the one that we provide by default, and you can deploy it completely natively to be within the Kubernetes instance, or you can deploy yourself the services that are required by ArmoniK. For instance, if your IT provides a managed MongoDB database, then you can use it directly, and it will be managed by them instead of being managed by your application support team. So we have three kinds of storages. The first one is a queue storage. This queue storage, we support any IMQP queue storage. So there are many of them: RabbitMQ, ActiveMQ, ArtemisMQ, MQ series from IBM, and many other that are implementing the AMQP protocols. So we can support any of them. We have the task metadata database, and this database is based on MongoDB. And we have what we call ArmoniK storage. This ArmoniK storage contains the data from the graph that we saw before, the input and output of the tasks. And the ArmoniK storage basically is a key value storage. And depending on the requirement of your systems, it can be something in memory, for instance, a Redis installation, or it can be something with a higher latency. For instance, you can use S3 storages. This latency is not an issue, as we will see just after. We have an overlapping between communication and computation, so the latency most of the time is completely invisible. So what do you need to run ArmoniK? Basically, what you need is a Kubernetes deployment. So if you are a developer, you can have that on your laptop. You can have that if you have a Linux, you can run Kubernetes on your laptop. If you have Windows, you can run Kubernetes into the WSL. And if you want to go into production, you can deploy on your on-premises Kubernetes. But you can also deploy on a managed services Kubernetes, for instance, EKS on AWS. You need to integrate some things. Of course, if you want to go into production, you need to integrate the secret manager. You need to integrate the authentication with your authentication system. And you can optionally integrate other systems. As I said before, the MongoDB database, the ArmoniK storage, the queue system, and the logging system. We use FluentBit as a proxy between our system and any logging system. So FluentBit is an open source software that is able to redirect log from one source, which in this case would be ArmoniK, to any backend that you want. So you have a very long list of supported backend on the FluentBit website. You can use Splunk, you can use all the logging system from the CSPs and so on and so on. We have some limitations as of today. The first one is we only support one data plane. Why is it a problem? It's a problem because the scheduler, the compute plane needs to get the data from the data plane, needs to get the data from the ArmoniK storage, need to get the task from the queue, and need to get the metadata from the MongoDB database. And here we have these access are quite frequent, and we do them quite a lot. So we need some kind of geographical proximity or network proximity between the data plane and the compute plane. And as a consequence of that, currently, when you deploy ArmoniK, you can deploy ArmoniK only in one region. You can deploy ArmoniK on your premises. If you have two data centers close one to each other, your deployment can be spread across the two data centers. But if they are too far away from each other, then you will need two deployments as of today. And currently, we only support Linux nodes. Windows has been tested, but it's not integrated yet. So if you have some requirement on dependencies that need to run on Windows, then you might we need to discuss to be sure that it will be well supported. Otherwise, we don't have so much very strong limitations for the use case that you have in finance. I said many times that ArmoniK is able to support communication and computation overlapping. So let me explain you very briefly how the scheduler works. The scheduler, as you can see on the schematic, is running on all the compute nodes. And the scheduler basically do three things. First thing that it does, it fetches the tasks from the queue. The second thing that it does, it will get the metadata from the queue and will do some checks. For instance, it will check that the task is not has not been in failure too many times before. It will check that the task has not been cancelled by the administrators and so on and so on. And the third thing that it will do when everything is okay is to send the task. And the third thing that it will do is to fetch the data from the ArmoniK storage. And when everything is ready, then the task and the data will be sent to the lib agent and will be run by your solver. While your solver is running, the assumption that we make is that your solver should not access other things if you want to take all the advantages of ArmoniK. So while your solver is running, we can use the scheduler to prepare the next task and to fetch the next metadata and to fetch the next input data from the ArmoniK storage. So when the first task computation is finished, the second one can start immediately, and so on and so on. This way, the scheduler is consuming the bandwidth, and your solver is consuming the compute power. So I said that we need some integration. So if you want to run ArmoniK on AWS, basically we have done all the integration with Crédit Agricole and AWS. So these are the services that we use to run ArmoniK on Kubernetes. So we are using EKS, of course, the managed Kubernetes service, and we are using all the managed services that are relevant for ArmoniK to reduce the TCO and to reduce the operational work for ArmoniK. We have tested, but it's not fully integrated yet, AWS Graviton processor, and they are working, but we don't have all the CI/CD tools built for them yet. And we plan on integrating the Carpenter autoscaler to increase the performances of the autoscaling performances of ArmoniK on AWS. If you want to integrate with GCP, this is a work that we will be doing, that we should be doing this year. And if you want an integration with Azure, for instance, that is something that we will do as soon as we have customer requests for that. Aneo provides professional services for ArmoniK because, as we said, ArmoniK is open source, so our business model is professional services oriented. So we can help you with POC and integration. Currently, we are mostly focusing the target in Europe and UK, and the other location have to be discussed. We'll be able to address some of them at the same time, but not many of them at the same time. And we also provide some other services dedicated to feature development. If you have some requests, you have some requirements, we can discuss them and integrate them within ArmoniK. And we can also provide level 3 support for ArmoniK. Some features that are coming in the next months. There is first a plugin system that will allow you to change some of the components. If you want to have your own ArmoniK storage, very custom and so on, you will be able to make this plugin. We want to implement the node level data cache to improve the performances and reduce the amount of data communication. And as I said before, we want to implement dynamic partitioning, which means that you will be able dynamically to add new partitions in your deployment, which will allow you to integrate new versions of your applications and new applications. And next year, we will be integrating multiple data planes within the deployment. We were able to make different data planes to communicate with each other, and this will allow for multi-region deployments. And as soon as we will have that, we'll be working on dynamic offloading, which means that you will be able to deploy some workload on one ArmoniK deployment on one region, for instance, on premises, and dynamically, depending on the load of your infrastructure and so on, it will be able to offload to a cloud environment. And of course, as I said, we'll be able to support other CSPs in production, and it will be done on a per customer request. And we have also an ongoing research and development to improve the scheduling algorithm so that it will be more data aware. Currently, we don't take into account the topology of the graph and the fact that some data can be reused and so on. And this is something that we are on which we are working right now. Now I will let Marcel introduce you to the story of the deployment of ArmoniK within Crédit Agricole.
Thanks, Thierry and Wilfried, and thanks for letting me share a feedback. So perhaps first, a bit of context related to CIB capital markets transformation, which started back 3 years back. So in 2020, we started our twofold transformation. So first item was an organizational transformation, first aligning IT and business from a product perspective, so creating dedicated front to back office to risk tribes. And then second part, which was linked to technology. And this was something which was really important because we were convinced with the fact that we had to lead those two transformations at the same time. So it was also to embrace the long-term CIB business ambitions. So this transformation was putting the emphasis on, I would say, architecture of our information system, but also pushing in-house new developments using practices and technologies of the moment. And especially the cloud, of course, I would say. So regarding our HPC and grid strategy, we were coming from a situation where any new request was leading to a batch of orders of new hardware installed on-prem, with, of course, as you may infer, increased cost, and last but not least, and especially during the COVID period, an extremely long lead time between the order of the servers and the effective delivery. So it was a real pain, and we had to move out from that situation. So the strategy was then to adjust, of course, and to focus on the cloud capacity, and of course the horizontal elasticity provided by the type of the cloud service provider. So there was also one point which was something which was that we had to take into account, was the growth linked to increased volumes on flow products, of course, and also on structured and exotic products, with, of course, a never-growing regulatory pressure on the capital markets environments. On top of these conjunctural environments, just like, I guess, every bank, there was a need to, or at least for reduced time to market, cost reduction through synergies and so on. So within CIB, we have several types of grids, and I would say I will describe the main one. So the first one is a grid linked to a multi-threaded architecture, which, and I will not go into the details on that architecture, but which leads to a direct-to-grid architecture based on first vendor orchestrator. The second one, which is also totally different, is based on a mono-threaded architecture, leveraging on subtasking mechanism, having a data cache hosted externally based on another vendor orchestrator. So we have two different architectures, but those two different architectures are really linked to their respective pricing libraries. So the target for us was to mutualize our calculation capacity, because today all those grids are separated, and of course you can't leverage on idle calls when another one is or another orchestrator is using the full capacity. So and this is one of our main targets. As you know, the calculation capacity is a scarce resource. So leveraging on the public cloud for their also horizontal elasticity and using our existing patrimony of bare metal servers is also something that we want to push forward, because we want to have a hybrid strategy and not using only the cloud. So we really want to have both items working all together. This is where ArmoniK enters the game. So bridging the gap between the two worlds. So the project, the implementation project, started in 2021 with many benefits. So the first one, technical one first, and as I was explaining, it will help at the end of the day reducing the fragmentation and increase synergies for our calculation platform. As I was saying, we have today two main platforms with a lot of different cores working in parallel. We want to mutualize, and also we want to create synergies between the two worlds. And then we also have another benefit that we want to push forward related to organizational. So the thing that has been explained by Wilfried a few minutes back is the fact that ArmoniK today is built open source and embracing all state-of-the-art technologies. This is something which has been very motivating for talents within the teams, and of course contributing to the construction of the solution while still leveraging, I would say, on internal constraints and the disparity of pricing architecture within CIB was something which was really a motivation for the teams within the time frame of the project. So there were two main approaches for that migration, which is still ongoing because we are today still not full ArmoniK. So the first one was for the first type of orchestrator, I would say a staging approach, implying a first migration from .NET to .NET 6 before the migration to the cloud. And this first migration was done using or leveraging on the existing vendor orchestrator that we're using. Then we, I would say, pushed a migration to Linux and set up all the Linux environments before starting moving to our ArmoniK. So this was phased. So first move to the cloud with the, I would say, the vendor orchestrator, and the prerequisite was to migrate to .NET Core. .NET 6, sorry, and then move to ArmoniK after having moved the vendor orchestrator to the cloud. This was a 18 months migration with the first go live that happened in October 2022. The second approach is a shorter approach that we had on the other orchestrator, where we decided to go directly to the cloud using ArmoniK and without using or leveraging on our vendor orchestrator. And this one also, so we went through the same process, migration to the .NET Core. But it was easier, and certainly easier, certainly because the architecture of that would say a set of applications or that set of pricing services that we were migrating was perhaps more recent than the other one. Overall, the experience has been very, very positive, and today ArmoniK is running, in production on both scopes. So it's not covering the full type of products that we have, but we are progressively adding new products and extending the scope. So it's not finalized yet, but it's on its way. We are still having on-prem calculation capacities, leveraging on the vendor orchestrator. The thing that you need to have in mind, and this is some figures that has been computed lately, running the same batches today on the cloud using ArmoniK is 20 to 25% faster than the batch we are running today on-prem, leveraging on existing orchestrator. So it's the question we had is it linked directly to ArmoniK or is it linked to the refactoring that we did? For sure, ArmoniK helped on this, and the way it was architectured is a game changer. And also for the small story, we had some data center issues in Paris a few months back, and I guess that everybody heard about it, and it was kind of shared because Google suffered a lot about it. The use of ArmoniK, leveraging on the horizontal elasticity of the cloud, has been instrumental to make sure that the SLAs that we had with our business were met and compensates the loss of part of that capacity that we had on-prem. So this is something which is really important and is a proof of the fact that that strategy was the good one because it helps mitigate that type of incidents. So overall, very big success, and apart from the technical results that it is providing, it has opened a new path of mutualization within CIB, while, of course, as I was explaining, motivating a lot of teams working on subjects. So we are very happy to be part of the journey and the global very, very positive feedback overall.
Okay, thanks a lot, Marcel. Now it's time for the questions. There is a first one that has been asked, and I invite all the persons that are listening to give in the chat some of their questions. The first one is probably for you, Wilfried. Are there any kind of limitations in terms of CPU that can be used with ArmoniK? Is Intel, AMD, Graviton, are they available? Can we mix them? Thanks.
Yes, thank you for the question. There is one limitation about the kind of CPU that you can use. It needs to be supported by .NET Core, which means that you can use any Intel or AMD or ARM processor, including Graviton one, but also including the processor from the European Processor Initiative and many others. And they are already working to support RISC processors in the future. So this is kind of a good solution if you want to have a hybrid solution for this kind of for this kind of CPUs. And we can also support a mixed deployment between x86 and ARM processors. You just need to have different Kubernetes deployments and have ArmoniK deployed on both of them. And this can be mixed within the same deployment, but you will probably need some help from us if you want to have this kind of very custom deployment.
Okay, perfect. Another question, which is then for Marcel. You talked about an 18-month integration. So could you give a hint on how many people were needed, both on development, infrastructure, to roughly have an idea of the staff needed?
Okay. So we were co-building the solution with Aneo. So it took 18 months, but certainly if the solution was ready off the shelf, it would have been shorter. So on the 18 months, we are talking about roughly 3 people full-time during 18 months. This is, I would say, the metric that you have to keep in mind. But once again, this is also those 18 months are including the work that we were doing with Aneo, making sure that the business requirements and how the orchestrator were working was fitting our need. So there was some back and forth and adjustments of the requirements, of course.
Okay, thanks a lot. Another question regarding private cloud. Somebody asked that they have their own private cloud. So is ArmoniK tuned to work also with private clouds?
Thank you for this question. As I said in the architecture, the main requirement for ArmoniK is the fact that it runs on Kubernetes. So if your private cloud is based on Kubernetes, or if your private cloud can host a Kubernetes cluster, then the answer is yes. And as far as I'm aware, almost all private cloud solutions will support Kubernetes. So unless you have a very custom deployment of a private cloud solution, you should be able to run Kubernetes on your private cloud. I would also add the fact that if you want non-Kubernetes based deployment of ArmoniK, for instance, if you are running on a HPC supercomputer or an HPC infrastructure, this is something we are working on a research basis right now. But we can have some discussion to discuss your use case, and we'll be able to tell you what can be done.
Okay, thanks a lot, Will. Another question, I think it will be again for you, Will, and if Marcel wants to elaborate. It's, do you provide any tools to easily investigate production problems or bugs?
In fact, that's one of the reasons we chose to run within Kubernetes, and it's the fact that you can deploy ArmoniK anywhere. And as ArmoniK is currently able to manage all the input and output of your solver, if your solver does not use other source of data, so it depends on how you write your application, it depends how you integrate ArmoniK within your application. But if your solver does not use any other external data, then you can take the input data from the production environment. You can download them, and you can run that on your development station. And on this station, you can attach your debugger to your compute library. And if you are using Visual Studio, for instance, then you can debug within Visual Studio as you are used to. It will be completely transparent.
Okay. Marcel, you're on mute.
To add on this one regarding CIB's experience, it has been plugged to our monitoring tool and also investigation facility. So we are based on open source stack, so Elasticsearch, and all the investigations that we are doing are based on Elastic and Kibana Grafana. So this is one of, I would say, one of the strengths of the solution. You can plug it to your in-house or I would say preferred monitoring solutions to investigate any production issue.
Okay, thanks a lot. There is another question. After that one, I will take a last one. So I invite all the people listening to potentially raise one of the questions they would like to ask, whether to Marcel or Wilfried. So Wilfried has explained the type of business model that Aneo is running, providing integration, providing support and professional services for potential extra features that you would like to add on top of ArmoniK. Maybe can you elaborate, I don't know if it's Wilfried or Marcel, on the type of integration help that Aneo is providing based on the experience of Crédit Agricole, maybe?
So Aneo today is providing the help to make sure that all your use cases are working perfectly. So this has been something that we have been experiencing now since the beginning of the project. While we were also co-constructing the solution, we were making sure that each use cases that we were having on ArmoniK were working pretty well, comparing them to the legacy. Our legacy vendor orchestrator. So Aneo is helping us on this, and as well they are providing L3 supports when we have issues in production. So we have today, at least on CIB side, using both services.
Yes, and to elaborate a little bit more, where we can help you in the process. We can help you before starting the integration. We can help you in addressing the assessment of the ID. We can help you in building the business model and so on. So addressing all the TCO and all the steps that will be required on your side to make this kind of migration. And once you've started to say, okay, we want to make a proof of concept, or we want to integrate ArmoniK within your solution, then we can help you in two ways. We can help you on your side, which means we can provide people to help you doing the jobs that you need to do. For instance, if you need to change your application so that it can use ArmoniK's APIs, or if you want to change the way your application is distributing its task using ArmoniK, we can provide you with skilled resources. But we can also provide you with dedicated libraries or dedicated tools that will help you integrating ArmoniK with some custom-made SDKs or things like that, depending on your use case. So we can really address the problem from the two sides. And of course, if we are helping you on the two sides of our team will be working together. So it will be smoother than otherwise.
Okay, so last question is about performances. Marcel, you explained that there is an increase in terms of performances, even though if you don't know where exactly it comes from. But maybe Wilfried, because it's something that is regularly asked by the clients that envisage to switch from their DataSynapse or Symphony to ArmoniK. So what, in terms of performance, how do you compare ArmoniK with DataSynapse, and are there any kind of limits already known today?
Okay, so I don't know how we compare to DataSynapse, except from the feedback from Crédit Agricole, because we don't run DataSynapse runs. What I can say is the fact that we are testing ArmoniK in many different kind of environments. and the tests that we are running, not on every releases, but almost are running on up to 30,000 workers. So if your worker is only one core, then it's 30,000 core. But in recent, if your worker are multi-threaded and can take in charge a whole machine, then it will mean 30,000 machines. So which is a lot of cores, with modern machines being almost 200 cores. So this is something from our point of view, it's scaling quite well up to this side. We want to address much bigger size. We know some limitations that are being addressed currently to be able to scale to more than 100,000 workers. And we have been also, our basic use case for the benchmarks is running computational graph with more than 4 million tasks. So these are quite big also, and we launched several of them at the same time. So we have a lot of benchmarks and tests about the performances, and they are running very often, depending on not on all merge in the main branch, but not so far from that.
Okay, thanks a lot. So I think we've been through all the questions that have been raised on the Webikio chat. So thanks a lot for everybody. Maybe one information is that, as you have, I think, well understood, the product is now bulletproofed because running for almost 1 year in production without any bugs at Crédit Agricole. A second European bank that is under NDA is currently running a proof of concept, and hopefully will go live probably end of this year. And we have a strong mark of interest of many different banks and industries in Europe, Northern Europe, and in the Northern America. So there will be soon, I hope, some good news that we could publish on the product. The ArmoniK website has been put in the chat, so you can have extra information there. And obviously, we remain at your disposal if you have any technical questions. And so that's time for the closure. Marcel, in the name of Aneo and AWS, because we are representing a tripartite partnership. Thank you a lot for having the courage to with Vincent Lacroix to start the adventure, which is a bet, but the bet is currently being transformed in a positive situation. So thank you for this, and thank you for being present today. So thanks for the public, and there will be a replay available soon on the platform and on the ArmoniK website probably. So thanks a lot. Have a nice end of day in Northern America and rest of day in Europe. Thanks a lot, and let's stay tuned on ArmoniK. Cheers.
Cheers. Bye.
Thank you. Bye bye.